When developing generative AI applications, getting amazing results from large language models, that's easy. Getting consistent, predictable results that you can put in front of your customers, that's more of a challenge. Today, we are going to show you how to overcome that challenge with prompt engineering. Prompt engineering allows you to get high-quality, predictable results from large language models. We will talk about some prompt engineering techniques and also some more advanced optimizations and best practices for Anthropic Claude 3 models. My name is Anastasia Zeveleka, and I'm a senior AI/ML specialist solutions architect with AWS. I'm joined today by Maggie Vo, who is the head of education and technical enablement at Anthropic. Let's get started. We are going to start today with what is prompt engineering and some common prompt engineering techniques. We will also look at some system designs around generative AI and large language models. Next, Maggie is going to talk to you about best practices for prompt engineering and advanced optimizations for Anthropic Claude models. And we are going to close with a call to action and some reference material for you to follow up on. OK, let's start with an example. What is 10 plus 10? I run it through a large language model, and the answer it gives me is 20. Well, that's a very simple problem to solve. We don't really need a calculator to verify it. Notice the question, though. It is quite vague. What is 10 plus 10? There could be many right answers. At the end of the day, I didn't ask the model to solve 10 plus 10. If I wanted to solve that, then I would have asked the model to do so. Let's think of this example as part of in the context of a math tutoring application that teaches students mathematical operations. Based on that, I show you these examples. 1 plus 1 is an addition problem. 1 minus 1 is a subtraction problem, and so on and so forth. Now, if I ask you the question, what is 10 plus 10, you have a lot more context in terms of the answer that I'm looking for. And you can give me the right answer. 10 plus 10 is an addition problem. It is exactly the same with large language models. When you give these models context, for example, data or examples, then you can bias the models to give you the output you're looking for. And that is exactly what prompt engineering or in-context learning is about. You influence the model output through the context and the prompt you provide. Let's look at another example. Here I'm using Amazon Bedrock. Amazon Bedrock is a fully managed service by AWS that gives you access to a large number of foundation models by different AI providers, including models from Anthropic. In Bedrock, you can use the chat playground. The chat playground allows you to very easily access any model from those that are available, send requests, and get answers back. So in my example, I'm using Claude 3 Sonnet. And I'm going to ask a question to the model and also set a persona. I'm saying, you are a high school physics teacher. Answer questions in one sentence. What is quantum entanglement? I send that to the model, and the model provides me with a response. Quantum entanglement is a phenomenon where two or more quantum particles become inextricably linked, such as the state of one particle cannot be described independently of the others, regardless of the distance between them. I'm going to send another question, this time with a different persona. You are an excited 5-year-old child who ate a lot of sugar. Answer questions in one sentence. What is quantum entanglement? Notice here that the answer is very different. This time, the model responds that quantum entanglement is when two particles become super-duper best friends. They do everything together. And even if they are far away from each other in the universe, it's as if they are connected by an invisible string. So there's a very important point here. I asked the model the exact same question. But because I set a different persona, I got two drastically different answers. The tone is different, the vocabulary is different. So when you're working on a use case, especially if you're building a chat interface, it is best practice to set a persona. That can really influence the model to respond in a way that represents the persona that you set. For example, you can say, you are a polite travel agent, or you are a helpful customer service assistant. Let's look now at some other simple techniques. One-shot prompting. Here on the screen, I have the user, and I also have the response. The user is the prompt that goes to the LLM, and the response is the response that the model sends back. And as part of the prompt, I specify a task, generate airport codes, and an example. I want to fly from Los Angeles to Miami. Then the response to that, airport codes, column, and then the airport codes in brackets. This is the format I'm expecting the response. And this is the format I show in my example. After that, I have the user's request. I want to fly from Dallas to San Francisco. Notice here that I go ahead and also start the response of the model. So I'm saying airport codes, column, opening brackets. With that, the LLM will respond to me with the airport codes in the format that I want. Maybe I have a downstream application that parses this output and provides and processes the data. So I expect this data to be in a specific format. With one-shot prompting is when you have one example. If you have multiple examples, then you have few-shot prompting. Few-shot prompting can be used for a number of use cases. A very common use case is a classification. So in this example, we want to classify tweets based on the sentiment, whether they are positive, negative, or neutral. I provide a task, and I provide one example per classification to the model. And after that, I add the end user's request, the end user's tweet. Notice here that I have the tweet in brackets. That means that I'm going to insert that actual tweet I want the model to classify later during runtime. I have code in my application that does that. Again, I start the model response. So I'm saying sentiment columns, and then the model responds with the output I want. OK, so we talked about one-shot prompting, few-shot prompting. Let's look at some more advanced optimization techniques. One is chain of thought, or COT. So chain of thought allows you to break down complex problems into individual steps. So the model not only provides you with the output you want, the answer you want, hopefully the right answer, but also the steps it took to reach that answer. The other technique, and a solution design pattern essentially, is retrieval augmented generation, or RAG. This is very popular. Most of the customers I work with today are either experimenting with RAG, or they already have a RAG solution in production. Imagine you have a number of documents that are internal to your organization, but external to the model. The model was not trained on these documents. You still want the model, though, to be able to reference these documents before it returns your response. You can do that with RAG. Retrieval, augmented generation. 3 steps. We will see them shortly in more detail. But let's start with chain of thought. Chain of thought was initially introduced by a paper called Chain of Thought Prompting and Elicits Reasoning in Large Language Models. In that paper, they start with a prompt. It's a standard it's a standard prompt. They provide a one-shot example. So they are saying, Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? And the answer is 11. After that, they provide a complex problem, a new question for the model to solve. Here it is. The cafeteria has 23 apples. If they use 20 to make lunch and bought 6 more, how many apples do they have? The response the model provides back is 27, and that's not the right response. The right response is 3 plus 6 equals 9. So how do they fix that? They didn't fine-tune the model. They didn't do additional pre-training. Instead, they used chain of thought. So we have exactly the same one-shot example, exactly the same new question, but this time we're getting the right answer. Why is that? Notice that the answer of the one-shot example is more elaborate. It contains the steps that lead to that specific answer. Roger has started with 5 balls, 2 cans of 3 tennis balls, each is 6 tennis balls, 5 plus 6 equals 11. The answer is 11. By showing to the model the steps, we bias again the model output, and the model provides us with all the steps and also the final answer. Now let's have a look at RAG in more detail. RAG is really split into 2 parts, and that's because we are dealing with a data store. The first part that you can see here is the ingestion of the data. Let's say you have documents internal to your organization that customer service agents use to answer frequently asked questions. You upload these documents to Amazon S3, and then that triggers an ingestion orchestrator. What that ingestion orchestrator does is that it will take these documents from Amazon S3 and will split them into chunks using an embeddings model. You can use an embeddings model from Amazon Bedrock. You use the embedding model to create mathematical representations of these chunks or vectors called embeddings. Why do you need the embeddings? Because you want to store them in a data store. Why do you want to use a data store? Because it's easy to do similarity search when using a data store. Do you always have to use a data store and an embeddings model? No, you don't. You can use any other solution that allows you to do search with natural language. A great example of that is Amazon Kedra, the AWS service that is very commonly used in RAG architectures. OK, let's look at the second part. Now we have the end user's question. What is the return policy? The user asks that question, and then the mobile client submits this request to a query orchestrator. The query orchestrator will take the question and convert that into embeddings. Again, it can use the embeddings model from Amazon Bedrock. Once it converts that into embeddings, it can perform a similarity search into the vector store that we have and retrieve the most relevant, the most useful documents to answer the user's question. And this is the retrieval part of RAG, the R. Once it does that, then it will take these top 3 documents, let's say, that it retrieved, and add them to the prompt. And this is the augmentation part of RAG. And finally, the last part is the generation. So the prompt containing the query and the retrieved documents will be sent to the LLM, and the model then will generate the response in natural language. So we talked about one-shot prompting, few-shot prompting, chain of thought, RAG. Now Maggie is going to talk to you about some more prompt engineering techniques, and she will also show you how to implement these high-level concepts using Anthropic Claude and Amazon Bedrock.
Thank you, Anastasia. Hi, everybody. Hope you're having a good time today at the summit so far. My name is Maggie, and I am Anthropic's head of technical education, as well as one of the founding members of Anthropic's prompt engineering team. Before I dive into prompt engineering, I want to tell you a little bit about myself, because I think it's quite relevant to this. Before I started at Anthropic, I had 0 technical bones in my body. And that might be surprising to you, given the job I have now and also the topics I'm going to be talking to you about. The key that I want to kind of emphasize here is that prompt engineering is not some sort of mystical dark art that's hard to understand, difficult to master. It's actually quite straightforward. You know, I came upon my own prompt engineering skills before I joined Anthropic by spending my free time, weekends, evenings, Playing around with the models, understanding their idiosyncrasies. They're all slightly different because they have different training data, training paradigms. And they're just through trial and error, through creative problem solving whenever I encountered any roadblocks, I was able to develop my own understanding of what techniques worked with which models. And this was long before talks like this one and comprehensive prompt engineering guides to guide me, so it was kind of a blind exploration. And the techniques I'm going to be talking about today, many of them were explored and discovered in the same way. Our prompt engineers sat down, encountered a problem, and just thought creatively about how we could probably solve this, and discovered some techniques that, through testing, not only were solving one use case, but could solve 2, 3, 4 use cases, enough that we were confident to put them up as general prompt engineering guides. But in general, you and I, we are at the beginning of this whole journey. Every model out there right now, I don't think anyone knows comprehensively all the techniques that are necessary to use them well. And so I encourage you to have this be the beginning of your prompt engineering journey. The techniques that I teach you here today hopefully will spark creativity and inspire you to try your own techniques when you encounter any difficulties. I think for all you know, you might be the next person to discover the next great prompt engineering technique, and if so, I look forward to hearing from you. So without further ado, let's get into the actual prompt engineering techniques themselves, using Claude, and explore how you can best use Claude. The first thing to understand about prompt engineering is that instructions really matter. You want to be specific, clear. You want to tell your models as much information and context as possible to actually get it to output what you want. Take a look at the 2 prompts I have up there. I think inherently you're already going to be able to tell that one of them is going to give you more of the results that you exactly want, because I'm telling it the exact word count that it might want to have, or what audience that it should have, or the tone. And these are things that the LLM won't be able to mind read for you. So if you don't have that, you're just going to rely on whatever the training was in order to have the model output. And the model will output something, just it may not be what you're looking for. The thing to understand is that models don't have the context that you might think it does. You can think of models a little bit like interns fresh to the job, where they're really smart, but they don't know how you think, how your company thinks. And these are the things you want to put inside your prompt so that models have necessary context in order to answer those questions and perform the way you want them to. Other professions in real life kind of are prompt engineering for humans, right? When we're relying on clarity, structure of thought, and communication in order to elicit what we want. So with that kind of as a baseline, let's talk about what prompting looks like. I want to talk about parts of a prompt. At Anthropic, we have a prompt structure that we generally use. This is not set in stone. Parts are very malleable. You can nix some or move parts around. But generally, if you kind of stick to this structure as a beginning point, it's going to serve you quite well in terms of how to structure prompts for Claude. You want to begin with task and tone context. So this is where you want to lay the groundwork for the kind of work that Claude's going to do, what kind of information Claude might be encountering, and in general, just a brief overview of how you want Claude to behave. This is not the detailed part. You just want a brief overview. Then you want to actually put all your background data up front. So all the RAG results, any images, any documents you want Claude to work with. You want to give it up front so that Claude has that as the background context to read the rest of the prompt that you're giving it. This might be different from how other models work, because some models work better with all the data given at the very end. So this is kind of one of those idiosyncrasies I'm talking about. This is probably the most important part of the structure, is that for Claude, you really want to put that information way up at the top, directly after a little bit of context, just so it has that as you work through the rest of your prompt. This is here now when you want to put the detailed descriptions, the rules, all the different guidelines you're going to give Claude as to how you want it to use the data you just gave it in order to perform its task. You may also want to follow up with some examples to underscore exactly the instructions you just gave, as well as any conversation history. You can either put it directly in the prompt, or you can put it in terms of the kind of messages. If you're doing our API format, we have a messages array, and you can just put it as previous turns of the conversation, or you can put it directly in the prompt itself. Towards the end, if you have a very long prompt, you may want to reiterate, right? Right now, I gave you a lot of instructions, but right now, what I want you to do is this specific thing. And any thinking step by step and output formatting that you might want, you put right here as well, towards the very end. This kind of You don't want to put the nitty-gritty output formatting at the beginning. You want to structure it right towards the end so it's the last thing the model remembers in order to actually do its output. And last but not least, a technique that I'll talk about later is pre-filling Claude's response. So you're able to actually put some text into Claude's mouth to have it think that it's already said that, and it'll continue text from there. This helps with model steerability and for you to just control more what Claude is going to output next. And we'll talk about that later. So with this kind of parts of a prompt structure in mind, let's dive into actually talking about prompt elements. One thing to understand is that not every element, as I said, is necessary, right? But when you're prompt engineering, you should err on the side of more versus less. You want to just get the best performing prompt possible and then optimize for latency and cost and things like that. You want to make sure the model can actually do the task that you want it to do, and then you work backwards from there. And as I mentioned in my intro, experimentation is really key here. I was driven to learn these techniques by just the belief that what I wanted to do was possible if only I knew how to get there. And I think that driving belief, that desire not to give up, allows me to push the frontier of what models were capable of back then, and still allows our prompt engineers to discover new techniques now. All right. So let's talk about engineering a good prompt and what the prompt engineering technique is like. In general, you want to think about prompt engineering as an actual science. It is not, as I said, some mystical art form. You're going to want to test your prompts and iterate very often. As such, you might be surprised to know that when you start prompt engineering, you're not actually starting by writing a prompt. You're starting by making your test cases. You want to understand what a good output is, right? What your golden answer is like, given a bunch of inputs. You want to make sure that you cover your edge cases. What happens if users input no data? What happens if it's just like 50 characters of the letter J or something, right? You want to understand how the model's going to behave in those scenarios because likely, in the real world, it will encounter those things. Only when you have your test cases set do you actually want to start developing your prompt. You engineer your first prompt, and then you go through the testing and development cycle, where you're using those test cases to refine your prompt and over time work to improve your prompt until it passes these test cases. Now lastly, before you actually publish it, you want to test your prompt against at least one held out set of test cases. And this is really important because in the prompt engineering process, you might start overfitting your prompt to what you're testing, right? So you want to make sure that you have a separate test case that you can test against to make sure that it's able to work in the real world. And of course, if it fails this held out eval, then this eval now becomes part of your iteration test suite, and you have to build a whole set of evals again until you finally, for the first time, can pass your held out test. And only then should you publish and share your polished prompt. And that's the full prompt engineering cycle that we tend to work through at Anthropic, and what I encourage you to try to do as well. It's just a lot of testing and iteration, but the heart of it is having good evals. OK, so with that being said, let's talk about some Claude-specific prompt engineering techniques. At the very baseline, you should use user-insistent role formatting. So this is an example of what it looks like in API format. And you notice the system prompt lives outside of our messages array, and then the messages use alternating user and assistant roles. And you have to always start with user, because that's kind of where the human part of the instructions is, and then the assistant is the response. The real first prompt engineering technique is to be clear and direct. However clear you think you are, I guarantee you can always be more clear. You can number and list your instructions, separate your prompt into different sections so that it's very clear. It's like writing a good essay or writing a good memo. You want to just make it very obvious and clear when things are sequential or how things are organized. I encourage you to give your prompt and your tasks to maybe a colleague or someone on your team who has just never worked on your project before, and just see if they can do what you're asking the model to do. And if they can, then chances are the model can. And if they can't, then whatever they're tripped up on, the model's definitely going to be tripped on, because your colleague likely has even more context than what the model does. Next thing I want to talk about is using examples. I think this is the most powerful and effective tool in order to troubleshoot any sort of problem. Claude has 200,000 tokens in its context window right now. That's a lot of space for a lot of examples. And whenever I work with clients who have trouble getting Claude to behave in a certain way, the first thing I always ask them is, have you given an example of what you're looking for? And usually that actually solves quite a few of their problems. So you want to just make sure you give Claude examples of common edge cases. And generally, if you have more examples, it just creates higher quality responses. And so if you're ever encountering trouble, the first thing you should try is always give Claude an example of what you're looking for. The next thing is chain of thought. So Anastasia talked a little bit about what chain of thought is, and this is Claude's chain of thought structure. You basically ask Claude to output its thinking, and then you can put it in thinking tags if you want to. We work in XML tags at Anthropic. And so you can ask it to put it in thinking tags, its answer in answer tags, and then you can use regular expressions to just extract out the answer portion if that's all you want in the final result. The key thing to understand about all models is that thinking step by step requires that you actually give it space to think. So no thinking actually happens if you're just saying, hey, think step by step, but give me only the answer. You actually have to, at runtime, give it space to output that. Which means, of course, that while intelligence increases by giving it space to think, you're also increasing your latency, so you have to assess whether or not your use case has space for that kind of technique. This also helps you troubleshoot Claude's logic. So if Claude's struggling with a task, especially one that has a huge list of steps, you can have it output its thinking as it goes, which may solve your problems in the first place if you're struggling with getting Claude to follow those instructions. But secondarily, you can see where Claude is getting tripped up. So that's Claude and chain of thought thinking. Next one is assigning roles. So role prompting is this thing where at the very beginning of your prompt, you just say, hey, you are a master documentation writer, or logic puzzle solver, or legal question answerer. And that primes Claude in a way that increases its performance for that specific use case. It also changes the tone and demeanor, right? So as Anastasia's example said, if you're a professor versus a 5-year-old, you're going to answer questions differently, and Claude's going to have different outputs. But role prompting specifically also helps with just increasing model intelligence and performance, especially for things like math and physics and more complicated use cases. So I highly encourage you to do some role prompting just at the very beginning of your prompts, just to put Claude in the right mindset, so to speak. The next one is to use XML tags. So as I mentioned before, Claude is trained on XML tags. Specifically, we use those quite a bit at Anthropic. And Claude understands other delimiters, hashtags in Markdown, for example. But we decided on XML tags because 1, it's very clear when a section begins or ends in XML. 2, XML tags are really token efficient compared to other methods of delineation. And 3, you can do it inline, right? So you can have XML tags directly in a message. And that helps set sections apart from each other. So in my example here, I write, hey, Claude, and that's meant to be me speaking to Claude. And then you have the rest of the email. But it's very unclear when it begins and ends in that context. So you can see that Claude actually responds, dear Claude, et cetera, et cetera. So setting it apart with email tags and so on is very helpful for Claude to understand when sections begin or end. And we made XML tags quite robust against all sorts of XML tags. So you can name it whatever you want to, as long as the beginning and the end ones are the exact same. There's no special secret sauce XML tags that you should always use in order for best performance. But using XML tags in general allows you to turn your prompts into prompt templates. And this is quite powerful because you're able to start testing on a wide variety of background data, right? You kind of want to think about prompts a little bit like functions in code. You want to separate your variables out from your actual prompt, and you never want to kind of put those together in a hard copy and paste way. And this allows you to run all sorts of different data points. So this is just a kind of an example of what happens when you're able to, let's say, test for 3 different sets of input data for the same prompt, and you're also able to edit the prompt separately from the data, which allows you to understand the prompt itself and what it's saying. For most enterprise prompts, it's quite long, right? You have many examples and all that stuff, and so the more you can abstract that out to understand the structure of your prompt versus the stuff you're putting inside it, the easier it is for you to troubleshoot. Further techniques are to pre-fill Claude's response. I mentioned this at the beginning when I was talking about prompt structure. So pre-filling Claude's response is something where you're able to just put text in the assistant field or the assistant role if you're using the API, and Claude will continue from where you left off as if Claude said that. This allows you to steer Claude's behavior and generally have greater control over output formatting. In my example, I gave it the opening bracket of the JSON that I'm trying to ask it to output, which is kind of like our very fast JSON mode, basically, where you could just kind of tell it it's meant to do JSON, and then you open with a bracket, and it'll just fill in from there. And this, you can imagine, expands into other types of prefill. Like if Claude is not focusing on a specific part of your examples or your instructions, you can have Claude in the assistant prefill say, sure, I'd love to help you focusing specifically on X, Y, and Z. And that kind of steers Claude's output and behavior to the prefill text so that it's kind of more honed in on that behavior. And then after all these techniques, I want to talk a little bit about how you can combine these techniques together to handle hallucinations and other troubleshooting. With hallucinations, there are a few things you should try, and this is generally for Claude. I imagine they also work for other models, is that you can give Claude permission to say, I don't know, if it doesn't actually know the answer. It might sound really simple, but sometimes Claude's desire to be helpful means that Claude thinks, I have to give you an answer, even if there isn't one. And so just to give Claude an out is actually quite powerful. You're able to just tell Claude there's a chance that there is no answer. If you're having Claude correct your mistakes, you can say there's a chance there is no mistake to correct, in which case just return to me what it was before. The more you tell Claude the wide range of possibilities as to what a correct answer is, the more it's able to not make up something in order to fulfill your criteria of what it thinks the correct answer should be. Claude also understands confidence a little bit. It's a little bit hard to go like 90, 95% confident in terms of numbers, but if you say something like very confident versus a little bit confident, that'll change how conservative Claude is in terms of what it responds with. So if you tell it to answer only if it's very confident in its response, it'll have more of a grounded answer in, if you're giving it RAG and things like that, it'll ground its answer more in the context of what you're giving it, and not answer based on less confidence or less evidence. Thinking step by step, as I mentioned, is also a great way to A, troubleshoot, and also B, have Claude actually think through its process, and then arrive at the answer, which makes sure that Claude is actually doing it logically and checking its own understanding before it produces the final output. And then lastly, if you have a really big chunk of text, let's say 30,000 tokens or more, you may want to ask Claude to hone it down a little bit. So you have Claude find the relevant quotes first, extract those quotes as step number 1, and then only using those quotes, tell Claude to do the task or answer the question. And that basically helps go from very big to a little bit smaller and more targeted, and then only focus on that to answer the question, which guarantees that Claude isn't, is less likely to get lost in the sauce of your very, very big document. There's also prompt injections, right, and bad user behavior, and how do you mitigate that? So Claude is already pretty highly resistant to prompt injections and bad user behavior, jailbreaking, things like that, due to our reinforcement learning techniques, constitutional AI, and other safety measures that we put into our models. We are the safest model on the market in terms of jailbreaking, robustness, things like that. But if you really want maximum protection, you can also run a harmlessness screen, either before or after. You can check Claude's outputs or check the inputs from a user and run it by whatever criteria you have, your acceptable use policy or whatever measures you want, and ask a smaller model, let's say Haiku versus Opus, to run some sort of query or screen to make sure that what the user is inputting isn't trying to jailbreak the model, or what Claude is outputting isn't harmful. You can have that extra layer of protection if you want to. A bonus I want to talk about is prompting with images. So now, Claude 3, all 3 models are vision capable, so it can take in images and text, which greatly increases the range of use cases you can use it for, but also at the same time, you have to know how to prompt for these images. As with any document, put the images first before you put your task, instructions, your query, et cetera. Enumerate the images if you can when you're referencing multiple images, just so that it's easy for you to say, hey, image 3, do something, something, image 4, et cetera. And then lastly, you might want to ask Claude to chain of thought the images a little bit. So describe the details in the image. Extract out all the numbers in these charts first, right? It's kind of a similar principle to pulling out key quotes from a long document. You want to have Claude analyze very carefully the image that it's working with and then do tasks based off of that analysis. With the last few minutes I have for you, I want to talk about some advanced capabilities that Claude is capable of. 2 specifically. First, tool use. Second, RAG. So tool use is basically when you add to Claude's functionality and expand its capabilities by giving it whatever tools that you're able to code. So that kind of basically expands Claude's capabilities to an infinite level of kind of use cases, because whatever you can code, you can give to Claude as a tool. The key to understand is that Claude doesn't directly run these functions. It only decides when to use these functions, and then it returns to you an output that says, hey, I would like to use these functions. And then on the client side, you actually run the actual functions and return to Claude the results. Diagrammatically, this is kind of how it works. You have a user question, the question comes in, you also give Claude a list of all the available tools that it has at its disposal, some descriptions as to when and how to use those tools, maybe even some examples if you have some really complex tools. And that goes all together into a single prompt, the tool use prompt. That prompt gets sent to Claude, and Claude judges the relevance of the tools against the user's question. So it makes the judgment, and then if it realizes the tools are not useful at all, then it just doesn't have the information to answer, so it'll respond, I apologize, I don't have access to the current weather in San Fran, for example, if we're asking for the weather. But if it does, then it'll return a tool request. And the format kind of differs right now based on what platform you're using, and so I encourage you to check out our documentation to understand which format works on what platform. But Claude outputs a tool request that has a very specific structure, so you can always look for that structure in terms of your stop sequences or when you're using regular expressions to analyze Claude's outputs. With that tool use request, it is on you to extract out what tool Claude is asking for, what parameters Claude is using with those tools, and then to get all that information and run the actual function on your side. You return those results to Claude, appending to the previous conversation. So now Claude has the full context of question, tools, tool query that it sent, tool results that came back, and then Claude is able to compile that information together and answer the question. And this is a simple tool use situation, but Claude is able to decide between quite a few tools, and we'll talk about that in future RAG slides. Claude's also able to handle, as you use smarter and smarter models, so Opus is able to handle many more tools than, let's say, Sonnet. And the cool thing about Opus, too, is that Opus is much better at recognizing when it doesn't have all the information it needs to actually run a tool. So you can have the user maybe say, get me the weather, and not tell you where. And Opus is better at recognizing, well, I still need the information for this specific tool. So I'll ask you, where are you looking for weather from? So all this is in our documentation. I highly recommend that you read it. If you want, I'll pause on this QR code screen if anyone wants to take a quick photo. You can also find it at docs.anthropic.com under tool use capabilities. So let's talk about RAG. As Anastasia was talking about, RAG is basically when you search for, retrieve, and add to the context window key information that Claude might need to know in order to perform its task. This is useful for a wide variety of ways. First is that it allows you to actually augment Claude's internal training data with external data that it doesn't have. Say, it gets data training cut off at a certain date. Now Claude has more up-to-date information beyond that if you're adding information that's more up-to-date. This also allows Claude to be more grounded in evidence. So if you're asking it a question about, Roman Empire history, if you give it some text about that, it's able to better ground its answer in whatever text was given in the context. And then lastly, this allows you to put your secure data into Claude without having, data needed to be trained into the model, no need to fine-tune the model. Sometimes we call, retrieval and augmented generation plus prompting as in-context fine-tuning because it really acts in a very similar way, much cheaper, and sometimes just as powerful, if not more. The basic RAG architecture looks like this. So you have a question that gets asked, and then you embed the query into the same vector space as the vector database. So you can have the similarity search between the query keywords and the results inside your database, and then pull out the relevant information that seems to match the most. Only then do you send all of those results to Claude, where Claude can use that context plus the question and generate the output. However, I encourage you to experiment with your RAG architectures and really expand it and use LLMs more on your behalf. The first thing you can do is use RAG as a tool. So instead of telling the model all the RAG results after you've already done the retrieval, you can give Claude the option of using RAG as a tool And so you have the tool use version of RAG now. You give it to Claude, and Claude decides, based on the question, is there a tool I can use to help me solve the problem? In this case, yes, you can search through the product database. So Claude uses the search products with a bunch of keywords that it creates based on what the user question was. Searches through the database, you search through the database, and you return the results to Claude, and then Claude can continue from there and give the results to the user. Now this is complex, but this actually saves you a lot of time. For example, there are many situations where you don't need to use RAG in order to answer the user's question. Right? You don't need to go through RAG every single time. So if Claude can make a choice for you, Claude can bypass that whole thing and just use RAG only when it's necessary. Second of all, it allows you to create one LLM structure that's quite robust, right? So you don't need to have a different RAG implementation for every single database, use case, et cetera. You can just have the model decide for you which database makes sense for it to use based on what the question is. And then lastly, you could have Claude rewrite your queries for you. So there's a lot of optimization in RAG that comes with chunking and re-ranking and figuring that all out. And you can use that technique in addition to having Claude just rewrite the queries. There's no guarantee that the first time you go through a database, you're actually getting the proper results, the best results. And so to have Claude rewrite your queries, different keywords and things like that, based on a certain criteria, let's say like 1 to 5 in terms of quality, and you get to define what that rubric is, right? There's no rubric that's built into Claude, but you can define exactly what you mean by high quality results. Have Claude compile only the best ones, and then using results of quality 4 or higher, answer the actual question. All of these can be together. Obviously, you can give Claude both the ability to rewrite the results, rewrite the queries, as well as multiple databases to choose from. And this kind of starts creating a much more complex architecture that's also more robust and able to handle a wider variety of use cases, as well as possibly saving you quite a bit of time, tokens, money, resources, et cetera. With all of this, I want to leave you with some prompting resources for you to continue your journey. As I said, this is really the beginning, and I encourage you to experiment, to try new things, to firmly live with the belief that whatever thing you want to try, it's likely possible if only you knew how to prompt it. And I have some prompt engineering techniques. We have even more at Anthropic other than the ones I showed you today, but those aren't all of them. And so experiment, try, think creatively about how you might approach a large language model, and then you might find something that works for your use case. The first thing, in terms of tooling that we have, is the experimental meta prompt. So the meta prompt is basically something where we are asking Claude to write a prompt template on your behalf, given a single sentence or two description about what you want the model to do, as well as any variables that you want to have. This meta prompt was built because we understand it's a little bit scary and daunting to go from a blank page to a fully fledged, complex prompt, several tens of thousands of tokens, that kind of thing. And so we mean it to be a starting point for you, to get you to a point where you feel comfortable editing your prompt instead of just building one from scratch. This meta prompt doesn't guarantee that it's optimized for your use case. There might be context that we're missing about certain things. And so we recommend that you iterate. You take the meta prompt's results, and then you try it, you eval it. We go back to evals all the time, having good evals. And so you evaluate it against your tests, and then improve it from there, but at least it'll get you going to quite a decently engineered prompt from the beginning. You can also check out the prompting resource portal, docs.anthropic.com. It contains our prompting guide. It contains a lot of the slides that I gave you today. It contains our prompt engineering tutorial. We have an interactive one, prompt library, all our API information, sample code, and so on. So we highly recommend you explore this and just kind of read through it at your own pace, or copy and paste it all into Claude and ask it some questions. So without further ado, I'm going to invite Anastasia back to talk about Bedrock docs, Bedrock workshop, and other calls to action.
Thank you so much, Maggie. So thank you, everyone, for joining us today. It's been wonderful having you here and sharing with you these best practices and insights. Here you can find the QR codes for the Bedrock documentation. Bedrock gives you access to the Anthropic Claude models, and you can practice all the techniques that Maggie spoke about today, and also a Bedrock workshop specific for Anthropic Claude 3. If you want to learn more, You can also visit the AWS Skill Builder portal, where you can find additional trainings and hands-on labs. And it comes with a free 7-day free trial, and it's built by AWS experts. Thank you so much for joining us today. Please take a few minutes to fill in the survey. We really love to hear your feedback, and enjoy the rest of the summit today. Thank you.
Thank you, everyone.